So we're going to use this equation over here, 2.94 gram sample, so that's the mass. Plug that in here, 2.94 gram sample of an unknown gas is found to occupy a volume of 2.06 liters. So 2.06 liters, we'll plug it in here. So if we know the mass to volume, I could calculate the density, but don't need to. We'll just plug those in here. At a pressure of 1.16 atmospheres, we'll plug in the pressure here, and a temperature of 46 degrees C. 46 degrees, that's the temperature here, converted to Kelvin, and then we know what R is. So we have all the numbers to calculate the molar mass, which you can do. And so this is the case where they just gave us, the mass and the volume, not the density. So we have the mass and the volume, and we don't need the density. But in some of these other examples, they give us the density. So let's go back up and look at number 15. 15, the STP density of an unknown gas is found to be 2.32 grams per liter. What is the molar mass of the gas? So in number 15, they give us the density. So I'm just going to use this equation here. And so the molar mass of the gas is equal to the density times R times T divided by P. So the density is going to be 2.32 grams per liter. R is 0.08206 liters times atmosphere divided by mole Kelvin. T is, well, this is standard temperature. What is standard temperature? What is standard temperature? 0 degrees Celsius, which in Kelvin would be what? 273 Kelvin. I don't know anybody who wants to work in the lab at 273 Kelvin. It'd be too cold. What's the standard pressure? Well, it depends. Are we going to go metric or are we going to go US? We're going to probably go metric here. Although, it's up in the air which one we go. So, standard pressure would be? 1 bar. This conversion factor you don't have to memorize. It's 1 atmosphere is equivalent to 1.01325 bar. There are 10 to the 5th pascals in a bar.
On the test, will we be allowed to choose either?
Mm-hmm.
Okay.
Well, no, I'll specify. If it's not specified, then you could choose either. If I specify it. In fact, you know what? STP, your book loves STP. I don't. And so you should know what STP is, but I'm not going to have any calculations to STP conditions. And so I'll just tell you what the pressure and I'll tell you what the temperature is rather than having to deal with it. All right, so what they did was they didn't, although they used different R values, for example, 4, they used the one for liters atmosphere here. And again, they only do it to 3 sig weeks. So I like it to 4 sig weeks, 0.08206. They rounded. But what they did was they just converted from atmospheres to bars. This is wrong here. I don't know where they got this. Weird. Oh, I know where they got that. That's from the equation here, pressure. Pressure's 1 bar. Now it makes sense. And so the molar mass they get is 52.7 grams per mole. So we just plug in and calculate. So that's molar mass determination. You can see some other examples of that. A sample of an unknown gas is found to have a density 2.00 grams per liter at a pressure of 0.939 atmospheres and a I guess we already looked at that one. The gas in an 8.07 liter cylinder at 13 degrees C has a mass of 33.5 grams. So we have the mass, we have the volume, and so we know the density. If we have the mass and the volume, we know the density. But we don't have to calculate the density. We can just plug it into this equation here, mass over volume. We have the pressure. And so if we have the mass, the volume, and the pressure, we need the temperature. What is the temperature? We have the temperature. And so we just plug everything into the equation and then solve. It's pretty straightforward. Molar mass is equal to mass times RT divided by PV. Plug everything in, it comes out to 30.0 grams per mole. A 2.01 mole sample of an unknown gas contained in a 5.00 liter flask is found to have a density of 1.72 grams per liter. What is the molar mass of the unknown gas? Well, we have the density here. We just need the temperature and the pressure. We have the density. Do we have the temperature and the pressure? No. So this is a variation of it. And in order to get the molar mass, we need the mass over moles. And so they're